We've worked with arithmetic and geometric sequences. We're now going to work on a special case, and that is recursion. With recursion, we're taking the first term, going to the next term, and the next term, and the next term. So it's a little bit different in the sense that I need the previous term. So if I need the sixth term, I need the fifth term in order to figure out how to get the sixth term. Okay, so with a recursion, we need the value of the first term, and we also know that the recursion is going to give me an equation that shows how to find each term from the term before. Okay, so that sounds kind of complicated, but it's really not. For instance, if they tell me that A1 equals 3, and then they also tell me that my formula an plus 1 equals 2an minus 1. Okay, so I want to find the next several terms. So I want to find A2, A3. Okay, so what is this n plus 1 thing? What is the an? So basically what you're going to do is you're going to take the term that they give you, whether that's a1 or a to the fourth, it doesn't matter. Just whatever number they give you. So my term then for that, I know that n then has to equal 1. So that's what's going to be plugged in to these spots. So I have a1 plus 1 equals 2 times a to the first minus 1. Okay, so I'm going to plug in the information that I know based on this. A to the 1 plus 1. That really means I'm finding a to the second, which is what we're looking for. So then I have 2 times, well, what is a to the 1? A to the 1 is 3 minus 1. So a2 then has to equal 5. So notice here, because it's n plus 1, I can't use a1 again in order to find a3. I have to use, in order to find a3, I have to take away 1. So I know that I'm going to have to use a2. So I have a2 plus 1 equals 2 times a2 minus 1. Well, I'm really looking for a3, so that's 2 times, well, what is a2? a2 is 5 minus 1. a3 then equals 9. Okay, so you need the previous term in order to find the current term that you are looking for. Okay, so for you guys, you need to find a5. Okay, I know all I'm doing is plugging in my a4. So I have a4 plus 1 equals negative 2 times a4 plus 6. So that's really a5 equals negative 2 times 7 plus 6. a5 is then negative 8. All right, and then there's going to be another, there's going to be a function notation with this. It's the exact same thing, it just looks a little bit different because we haven't worked with functions yet. We've just been working with general equations. So for instance, they're going to give you f of x equals, say, 9x minus 2, and they're going to say x0 equals 2. And I need to find the next 3 terms, or 2 terms, whatever it is. So this is the same thing. This right here gives me the A1, and this right here is my formula. Okay, so it looks confusing, but it's really the same process. So I'm going to have, if I'm looking for f of x1, that's going to equal 9 times x0 minus 2. Okay, so what does that mean? I'm just going to plug it in. 9 times 2 minus 2 equals 16, so x1 equals 16. Okay, so then how do I find the next term? So f of x2 equals then 9 times x1 minus 2, and I just plug that information in again. So in this case, I have 9 times 16 minus 2 gives me 142. Okay, so it's the exact same process, it just looks a little bit different. Just as a double check here, you guys are going to have f of x equals 3x plus 5, and x to the 0 equals negative 4. I want you guys to find x1 and x2. So looking at this, I'm going to go ahead and plug my information in. So x1 equals negative 7. To get f of x2, x2 then equals negative 21 plus 5 gives me negative 16. Okay, so all you need is the previous term in order to use recursion.